Okay, here's a quick little supplemental video to section 5.5, the triangle inequality theorem. So first, here is the triangle inequality theorem. It states that for a triangle, the sum of any two sides has to be more than the third side. It doesn't matter which two pair of sides you pick, you add them together, you got to get more than the third. I showed this to you in class here, but just to kind of go through it again, this little video, someone else made this, that's why they have the smiley face, not me. But here's a little example of how this works out. Right now, all the sides are the exact same length, so we get an equilateral triangle. We know that's possible. What isn't possible is if the two sides aren't long enough to make a triangle. So if we said, let's say B is 2 and A is 2, those two guys just aren't big enough to make up even the whole segment. The other way this doesn't work is if they're equal to, let's say A is 4. I'll set A equal to 4. There's A is 4, that makes B is 2, and what ends up happening is, as you can see, they just collapse on top of themselves to make C, which is the full length. Now if I make C just a little smaller though, it now is small enough that they're big enough to kind of open up as a triangle. So that's all it says, is if you have any two sides of a triangle, you have to be able to add them together to be more than the third. If that's not possible, you don't have a triangle. So let's take a look at a few examples from the book. First, example 1A out of the textbook, they want to know, is this triangle possible with these three sides of 15, 16, and 30? You can do all three sides and do all three different combinations and pairs or whatever, but really all you need to look at is the two shortest sides. Because if the two shortest sides can't add up to make the third side, it doesn't matter what you add together, because that's your pair you're concerned with. So in our case, the two smallest sides are 15 and 16. If you add 15 and 16 together, you get 31. Hey, 31 is more than 30, so yes. On 1B, however, your two sides are 2 and 8 for the shortest sides. If I add 2 and 8 together, I only get 10. 10 is less than 11, so no, it doesn't work. And on your homework, or on the test, your quiz, whatever you want, or your test, you need to show me some kind of justification more than just yes or no. Now, on problem 2 from the guide to practice, this one is a little more algebraic. So, and you have to kind of go through almost by a process of elimination manner to sort this out. So the question is, which of the following could not be the value of n? You could just pick and choose and add them all up, but I want to show you the algebraic way to do it, and then we'll knock out what these two sides aren't, or which side doesn't work out. So the first thing you have to assume is that, let's assume n is the smallest side. It looks it by the drawing, but we don't know that for sure. It could be bigger. But if we assume it's the smallest, that means 9 is, the next smallest, and 13 is the biggest. So n plus 9 has to be bigger than 13. We know that if n is the smallest. So solve for n, we get n, by subtracting 9, we get n is greater than 4. So we know for a minimum, n is greater than 4. I'm going to fill in the other side here in a second when n is less than. The other situation is, maybe n is the biggest. Okay. If it's between 9 and 13, it doesn't matter. Our concern is, what if it's bigger than everything else? Well, that would have to mean that 13 plus 9 has to be bigger than n. Meaning 22 is greater than n. Meaning that n is less than 22, or more importantly, n has to fit between 4 and 22. Because if n is bigger than 22, say 23, let's imagine for a moment, 13 plus 9 is only 22, it's not bigger than that side, so 23 can't be that side length. So the two things you have to take into consideration is this missing side the smallest side, or actually, I guess middle side even. It could be, between 4 and, it could, whatever. But we know that 13 is the biggest side because it's the biggest one given, or n is the biggest side, so we'll set those up for those two different inequalities. And this is our range now. And then we look at our answers. 4 is bigger than 7. Sorry, scratch that. 7 is bigger than 4, but less than 22. 13 is bigger than 4, but less than 22. 10 is bigger than 4, but less than 22. Oh, 22 equals 22. Not possible. It would collapse upon itself. And then one last example real quick. A proof. So, we're given that angle BCD and angle CDB are congruent. So C and D, both those, well, BDC really. We could use a single letter name for this one, but this one we have to use a three-letter name because there's multiple angle Ds here. We're told they are congruent. We want to prove, however, that AB, which is this side, plus AD, which is this side, is more than BC. Now the issue is, BC is not part of that triangle that these two guys are a part of. It's part of a bigger quadrilateral if I want to relate all three of them. However, the first key and insight to this problem is realizing, oh, these angles are congruent, meaning these two sides are congruent by the isosceles triangle theorem. Now that I know that, I can do my given and my statements and reasons. So statements, reasons. 1, given angle BCD is congruent to angle CDB. That's given. 2, I know by the triangle inequality theorem that AB plus AD has to be greater than BD. That's the triangle inequality theorem. Now I went out of order here, and I apologize, and it's too late to fix this. So really this step 2 should actually be step 3. My step 2 really should have been, so I'll just put a little 3 here. Step 3, sorry about that. Step 2 really should have been that BD is congruent to BC by the isosceles triangle theorem, because I have base angles of this bigger isosceles triangle BDC. So those two sides are congruent. By the triangle inequality theorem, I know that AB and AD add together to be more than BD. Now what I can do is replace BD with BC. So step 4, AB plus AD is greater than BC by substitution. Okay. So there's the formal steps for it. Okay. The idea again is it's more complicated, I think, to explain in the proof than it is to explain realistically. You know those base angles are congruent. You know that means this is an isosceles triangle. You also know that by the triangle inequality theorem, any two sides added together have to be more than the third. So AB plus AD has to be more than BD. Well, if BD and BC are the same, and AB plus AD is more than BD, AB plus AD has to be more than BC. Okay, and that's it for this lesson.